Okay, so this is chapter 9 about this semester. We call that clustering. Clustering, 分群 in Chinese. It's a unsupervised learning, 非监督式的方法。There are a lot of important algorithms. 有很多重要的演算法 but today we will just introduce the K-means. So what is clustering analysis? Chinese 群集分析。好。Find groups of objects. 我们把这些资料找到 groups, such as the objects in a group will be similar. 在同一群里面呢，会比较相似 ，similar or related. 群内相似 to one another and different from the unrelated groups. So it means here there are 3 groups here and intra-cluster distance are minimized. 就是群内的距离要最小化。And the inter-class distance are maximized. 我们希望群跟群之间的距离是最大化。好 ，What is not cluster analysis? Supervised classification is not cluster analysis. What are the differences? Supervised classification have a label, but cluster analysis do not have a target variable. 就是分群法没有目标变数。So when the data have a class label, it's not cluster analysis. And a simple segmentation 就是我们单纯 divided the students into different registration groups alphabetically by last name. 就是我们比如说姓氏 A 开头的一群，姓氏 B 开头的一群，这样不行。或者是 only use a single variable， 只用什么单一的变数，性别，或者是年龄，或者是收入 ，etc. Age, your age, your income, your gender. To separate the data, just use one single variable that is not clustering, or its results of a requiring 就是查询的结果也不算 because grouping the result in the external rules or constraints is just the feedback of the query that is not cluster analysis. So it means when we mention cluster analysis, 就是所有变数要同时考虑。We consider all the attributes in the same time. 那考虑的是彼此每一个变数之间的关系。There is no target variable. So graphing partition is not also clustering analysis because it's simply partition an image into smaller units. There is no concept of grouping data together because they are similar. So notion, clusters can be ambiguous. For example, how many clusters here? You think how many clusters here? 好，有个蛮重要的哦，在这边哦 ，cluster analysis 是群集分析，对不对？如果你加了 ing 也叫群集 ，clustering ing also 我们叫群集，但是 but when you use like a nouns, it's clusters 就是问有几群 ，how many clusters? It's one clusters. It's 2 clusters, so there are totally 2 clusters here. Yeah, maybe we will say it's 2 clusters, but you may say, Professor, I think it is 6 clusters. 就是如果我这样看 I can say that it's 6. It's good. Okay, so what is the exactly answer? Is 2 clusters correct or 6 clusters correct? I think both, because we can also say if we consider this point is make these 2 clusters can combine, and this point can make these 2 clusters can combine, then we can say it's 4 clusters. So the cluster number of clusters will be very ambiguous. 就是到底是几群这件事是蛮模糊的，取决于你要分的多细，好，跟你的间距。So there are some types of clustering. Clustering refer an algorithmic process, while clusters are the groups produced by the clustering algorithm. 所以 clustering 是演算法，把 clusters 那是那个群数 are the resulting groups produced by the clustering algorithm. So key differences between hierarchical and partitional clustering. So there are 2 types. One is partitional clustering, 分割式分群。Partitional clustering divides the data objects into non-overlap subset clusters, such as each data object belongs to exactly one cluster. But hierarchical clustering Hierarchical clustering produces a set of nested clusters， 就是巢状的群which are organized as a hierarchical tree structure like a dendrogram 它像是一个树状的结构，是一个直方图For example, the first is partitional clustering， 分割式分群。So original points just like this, and partitional is make it smaller. So original is every point here, but partitional means I will divide it into partition and not overlap. So each point will exactly belong one group. So in this case, there are 3 clusters. 在这个 case 我们是3群。Okay. But hierarchical clustering 叫做阶层式分群。It considered just like this. First, point 2 and point 3 is close, right? 2跟3是最接近的。So we combine point 2 and point 3 first. Then 1跟4谁跟它比较近呢？这里已经合并了。Here we have already combined. Good. So we will pick the central point 中心点 as the group representative. So in this point, which one is more closer? P4 or P1? Answer me. P4 or P1? P4, right? Isn't it? Yeah. So next, we will combine with the P4. 所以下一个合并的是 P4， 最后是 P1. So 阶层式分群 hierarchical clustering will make each point combine. Finally, just one group. But hierarchical is only one group original. 然后我们 divide partition, then will become 3 groups. 所以这个是从一个 one cluster make into 3 clusters. But in hierarchical, original have 4 points, but finally combine in one cluster. 这个是小变成多的合并本来是散变成合并的。And the distance is very important. 这个可以帮助我们判断我们要在哪里分群那也可以 it's traditional 也可以两先合并 non-traditional 是像这样Okay, so clustering algorithm there have lots k-means and its variants 就是 k-means 跟它的变形 and hierarchical clustering and density-based clustering. But today we just mentioned the first one. 好，我们只讨论第一个 k-means. But I want you to know 这个是will appear in your essay. How many clustering algorithm? Because when you go to apply a job position, there will be a question, right? But you know one of that is usually most common. 这是最常见的 But the others are most getting popular. Especially hierarchical clustering 在多变量可能有机会碰到 and you will have the chance to face the hierarchical clustering in the multivariate variation 那 density based 基于密度的呢是 DBSCM but I want to know DBSCM means density 是密度 based spatial clustering of application with noise 这个是跟噪音有关的Okay, so we only talk about the first one, k-means. K-means clustering algorithm, it is a partitional. 它是一个切割的分群方法 So each cluster is associated with a centroid, 质量的中心 centroid, 质心So each point will assign into the cluster with the closest centroid. 所以一个点会被分到哪里呢？就看 which is the most similar closest centroid 最接近的质量中心 And next, how many clusters 要分几群呢？那就是 depends on 你必须要事先 specify， 你要事先定义你要分几群。K must because the K means 的这个 K different from the KNN is different from KNN. This K is how many clusters must be specified. 要事先定义 but it based on the experience or the data. Okay, the basic algorithm is very simple. 这个要记起来哈，非常的简单。Okay. Initially, we select k points in the initial centroid. 就是随机 random, we pick the k points as the initial centroid, and we do the repeat. So this is while loop. 这是一个while 回圈。Repeat until the centroid do not change. 什么时候停？ The centroid 直心不再改变。So initially we have a k 的直心 by assign all the points to the closest centroid. 就是每一个人都去选跟它最接近的直心。选了之后呢 ，we will recompute the centroid for each cluster. 因为你重新算的直心 ，then because you recompute the centroid, so 我们就会重新选谁离我们最近，那个质量的中心会是谁 ，and we'll do the loop until no centroids change. So I will give you some point, just like this. See, originally it's data set just like this, but we don't know the color. I just let you see, just like the 3 clusters here. We use the k-means. The best situation may be this. The worst, the second, the suboptima is like this. 这也是 k-means 的结果。And I will give you the iteration. First, the data I will give you 3 points. 我跟你讲3区 is the first, D round. And everyone will pick the more close the centroid. Centroid 会是虚拟的，也可以是 exactly that point. Okay. So this part will be the brown, this part will be blue, this part will be green. And when we do that, these points will recompute their centroid. 它的质量中心会跑，因为它的成员是这些，一开始是 random 的 ，initial is random. Okay, so next, it will become this position. So some point between brown and green will determine which one. For example, this point. Originally, I have green, but when the centroid moved, 这直心移动了 I think I'm more similar or close to the brown, so I join the brown. 所以我加入了咖啡色这一群。When I join the brown groups, 这个成员是不是也变了？每个人成员都变了，那它的直心会不会移动？ Will it move the centroid? Yes. 它的直心会再往下一个移动，然后这个直心就会再往下跑，然后再往下跑，一直到没有人改变 ，until the centroid is no move. The centroid no move means 没有点是移动的，好，你的直心不再动，就代表 there is no point is moved to other groups, so it's stop. We can see the iteration. 这是第一个迭代 iteration. The second round, second iteration. Third round, fourth round, fifth round, and sixth round. And we can see the fifth round and sixth round, it almost didn't move any points. So the final centroid just move a little bit. 只有一点点的差异而已。好，这个就是 clustering. And then we will see another details here. 好，一些细节。First, initial centroids are often chosen randomly. Okay, so cluster will produce vary from one round to another. So when our randomness is different, the initial k means the centroids were different. 就是你一开始选的直心呢，会因为你的 randomness 的会非常差异很大。好，那 how do we know? 那我们在选的时候呢 ，typically the centroid is the mean of the point of the clusters. 所以你的直心就是每一个变数的平均数。那如果你是 categorical, if you are categorical nominal attribute, it will be mode 众数。If you are numeric, it will be mean. 如果你是数值型，那就是平均数。And the closeness is measured by Euclidean distance. 用的是欧几里的距离，在算彼此之间的距离。或者是如果 if you are document, 文字探勘 we are use the cosine similarity, we use the task mining. And sometimes we will use a correlation, but I think Euclidean distance is the most common measure here. So the k-means will coverages for common similarity measures mentioned above. most of the coverages happen in the first few iterations。在一开始的前几轮呢，大家的这个收敛呢会非常的明显。So often stopping conditions change to until relatively few points change clusters, or sometimes 我们会说好500迭代，不管它在哪里就停住了。So sometimes we will give the fixed iteration. For example, sometimes we will give the parameters iterations 200，就是跑200次，它最后在哪里就在哪里啊。OK， 如果资料量很大。OK， it's the complexity is big O， 这个很重要哦。Please make a notes. When we compute the k-means， 它会有4个影响到它的时间 complexity。what will affect the k-means computing time？ 因为算力 computing power is very important. N means how many data points will affect the time, and the K how many clusters will affect the time, and how many iteration 你要跑几个迭代 is I, and how many dimension means how many attributes 就是资料量 number of points, how many clusters, and how many iterations, and how many attributes will affect how many time you compute the k-means. So I would have already told you the best situation is this way, but in this case, it means originally I give 2 nodes apart and 1 node here part, the lower part. So no matter what, how many loops, how many times, it will become 2 clusters upside, 1 cluster this side. So the initial point is very important. 所以一开始的那个点很重要。So this is the case 1. So how do we know this k-means is good or not? Because the initial clusters is very different from and result a different result. 就是一开始你给的起始点执行会导致后面的结果完全的不同。所以我们要怎么知道哪一个比较好呢 ？Evaluating k-means clusters. You can use the sum of square error here. It's very important. SSE, sum of square error. The smaller SSE means it produces a better result. So for each point, the error is the distance to the nearest cluster, right? So to get SSE, we square this error and sum them. We square and sum the error. So we get SSE. So this is the formula. It means each point, X is a data point in the clusters CI. 就是我是 CI 的其中一个点 I belongs to CI, and I will compute the distance with the MI. MI is our centroid. Cluster I centroid. I will compute the distance, and the distance have to square because distance have to be positive, right? And we summarize all the clusters in CI, and there are K clusters. Means when we have 3 clusters, C1, C2, C3. When I do the first C1 cluster, 总共加起来，你会有第一群的 SSE and summarize the cluster 2 and summarize the cluster 3 and summarize all 就是这个，所以后面这个里面的这个加总是第一个 summation， 这3个加总是第2个 summation。So it means we can show the MI corresponds to the center means of the cluster. So give 2 clusters, we can choose the one with the smallest error. So SSE is smaller, this means it's better. But one easy way to reduce SSE is increase K. For example, 如果我有100的资料，我说我分 K 群是等于100，那是不是自己一个人一群，然后距离0，对吧？ You can, the number of clusters. So I want the K smaller, and the lower SSE is the best. For example, when the SSE one is 4 cluster and SSE is 1,000, the other is 2 cluster and SSE is also 1,000. Which one is better? 两个都是 SSE 一样，群数少的优胜，因为群数多的要得到高的 SSE 比较容易。 群数少的优胜。The smaller k is the better. Okay, so this is another case. 刚刚那个是本来就三角形的初始点 ，but this one is up, middle, down. 一开始就这样，好给你看哦。This is the first iteration, and this is the second round, third round, and the fourth round, fifth round, and finally it will just like up, middle, down. So it means different centroid 就是不一样的执行会导致不一样的结果。所以我们要怎么解决？多跑几次 ，use a different random seed， 这是一个。另外一个呢，就是我们使用一个算法叫 k-means 加加。k-means 加加 means it's a parameter。一开始选 k-means 的执行的时候，就让它选彼此的点要距离越远越好。一开始就撒得远一点点，好，一开始就撒得远一点点，好，这是这个 k-means 加加。And when we use the 欧几里得，注意咯，只要有欧几里得就要标准化。好，我们来复习一下 ，in this semester。How many algorithms 是有做标准化的 ？In this semester, very important 哦。哪些？有做 ，we have do the standard scalar KNN, right? SVN, right? K-means. When we means this, we have to standardization. 这三个要哦。所以同学们，你看到 ，when you see the reports from your classmates, do not mention he used the standardization for these three algorithms is wrong. 其他的数的系列 random forest 不需要，好，然后 decision tree 不需要，好，可以吗？可以吗？好 ，Then I will ask you， 那个 voting 需不需要？投票，集成分析法 voting 需不需要 ？Is voting need standardization？只要里面它用的方法有用到 ，just one of the voting methods need the standardization. All the methods have two standardization. 就是你 voting 里面的方法有用到需要 one of these， 就是这些需要相似度的 ，then your voting needs standardization. 所以大部分 most of the case the voting needs standardization just because when you use the voting, there are a lot of algorithms. So one of the algorithms use one of these. We need two standardization. Understand? Yes, thank you. So solutions to initial centroid problem, many rounds, 考很多次. This is the first method. The second method helps, but probably is not on your side. The second, we use the hierarchical centroid. 所以这个方法 this hierarchical clustering can help us to find the suitable initial centroid. And the method 3, select more than k and choose the most selected among these initial centroids. Select the most widely separated. And we use the k-means 加加. It's most common used here. 在现在在业界最常用的 use this algorithm. This algorithm means it initially will select more than k and we will select most widely separated. So, and the method 4, post-processing, 就是 you do all the things after, then we will find which one may be the best. And this 16 k-means 这是另外一个方法的。But I think maybe I will choose let you know. Let me know. Maybe tell me 3 methods. I provide 5, but actually tell me 3 methods is useful for initial centroid problem because we know initial centroid difference will lead to different results. Okay, 这个方法 accepting k-means not as susceptible to the initialization issue. 它是非球状的资料比较合适 So we will use it in Python now. So data suitable for k-means. Who suitable for k-means? K-means clustering assume the data is convex 凸形的 and isotropic 等向型的。K means it's less effective for clustering, elongate the shapes or irregular cluster. 就是 when the data just like this 这种长条的 it will be not good. It will be not good. Okay, and an equal variance, and the data the size is different. 这个少、中、多也很难或者是你的形状不是球状的your shape is different. It's just not like these two. So these two more better for use the K-means. So 我们才会有其他的方法。For example, 密度为基准的 DBSCN, just like this. So today we use the Python in the cluster.k-means. K 跟 M 是大写哦。可以吗？ Then we use the data that we are very familiar, and then we just use the age and income continuous variable because they are continuous variable and they contain 600 data. So, okay. This is our data set, right? And we will use the K-means K means the double class. So please go to the trunk class and use the spider. I will provide you the data set. Here, this is the data set here. Please download it. Okay, I'm afraid it's too long. 太长了，所以我们在这边先断开，然后程式码的是在下一段，这样转档才不会转很久。